Well, welcome everybody. My name is Hugo. I'm an independent developer at Little Robots, which is my company. And I'm also a Google developer expert for Android. And today I'm going to talk about RxJava. And the title is RxJava for the rest of us, RxJava 2 for the rest of us. Mainly because as a freelancer, I'm doing a lot of projects. I encounter RxJava a lot. I also see a lot of weirdness around RxJava, so I think that not everybody is always getting it or has some problems with it. And the same is true for me still after using it for a couple of years. There are still surprising things. There are still caveats. So what I would like to do today is give you, on the one hand, a practical introduction to RxJava by showing you some real-life code and also give you some tips and tricks pertaining RxJava. So this presentation is mainly just in general RxJava, but there are some changes for RxJava 2, so I will point them out where they make sense. Who's already using RxJava 1 in an application? Not too many. RxJava 2? Okay, a couple. Okay, so this is probably good to know. If this doesn't tell you anything, it's also fine. It's just informational. So RxJava 2 is a total rewrite of RxJava. There are a couple of important things here. One of the important things is that RxJava 1 used to have this concept of back pressure, but the problem is that it wasn't consistently implemented in all types. So what might happen that in some cases it worked, in some cases it didn't. In RxJava 2 they split up observable and flowable and made flowable fully support back pressure everywhere, and observable is the type which doesn't support back pressure. So if you have an observable that emits a lot of events that you can't follow, then you probably need to use flowable, but in the general case you probably are using observable or one of the specialized types. RxJava 2 is using a new package ID, so you can use RxJava 1 and RxJava 2 alongside if you want. There's some bridge code as well to do so. Well, I would recommend to switch over if you're already on RxJava 1. It's also modeled to the Reactive Stream specification, which means it's consistent with other implementations of the Reactive Stream specification. On the server side, that would mean that you could switch out implementations maybe. It uses some less allocations, but it has a larger method count, which is relevant for Android, of course. But yeah, if you're starting a project now, you should really go with RxJava 2 because by next year, RxJava 1 will basically be deprecated. So that was the mini RxJava 1 versus RxJava 2. I will point out differences between both during the presentation. But why would you even consider using RxJava at all? What problems are we solving? So take this typical piece of code where you want to get access to an article. And if you're really on the lucky path, this is all synchronous. You just call get article, you get it, and we're done. Maybe it throws the exception or not, but it's really simple. In real life, though, it's not that simple because usually that article or whatever you need to fetch comes from the network, comes from the database. It's not a synchronous call. You can't really block the main thread for that kind of stuff. So what you might end up with is something like this, where you have a get article that takes a callback. And a callback is basically nothing more or less than an interface that gets invoked once the result is in. So you call this method with callback, it starts executing, and at some point it gives you a result or it gives you an error. Well, callback has a couple of annoyances here. First of all, it's really hard to orchestrate multiple callbacks. So if you have to do multiple calls and you have to, for example, first fetch an article ID and then fetch the article, you end up with callbacks within callbacks. It's kind of annoying. Another problem is there's no real standard way to cancel these callbacks. Once this starts executing, it starts executing and it returns whenever it wants to return. And this might be a problem when you're dealing with Android due to the lifecycle callbacks, for example. You don't want to call something on a fragment when the activity is already destroyed, for example. That doesn't make sense. And it will crash your app. And the third problem is that for a callback, there's no a real sensible way to know if this callback will return on which thread it will return. Generally on Android, you want your results coming back on the main thread because then you can update your UI and stuff. So there's no, it might be coming back on the main thread, might be coming back on some background thread, and then you have to do all kinds of things using handlers or whatnot to make sure you're on the main thread. So async task is another variation of a background task, which tries to solve some of these problems. It's cancelable by default. You can call cancel on an async task. It also makes sure that your background work runs on the background thread but comes back on the main thread. So in that sense, it's all good, but still very complicated to orchestrate multiple async tasks. And it's also no standardized way to do any error handling. If we would take the reactive approach by using the observable type in RxJava, we would end up with something like this, where we have a declaration of a method that just returns an observable of article. And this is a kind of interesting concept because for multiple reasons, nothing is really being executed when you call this method. So unlike a callback, nothing is really happening. This also means that you can now take this observable that you got and you can pass it around to other places where you might need this result. So that's one benefit. Secondly, you can't really tell from this declaration if this will be synchronous or asynchronous. That really depends on how this observable is constructed. But if it's asynchronous, you can also always cancel it. So that's a standardized way. And there's also a standardized way to handle errors, which is, of course, very convenient. So again, this is just returning an object. Nothing is executed until you subscribe to it. This is important to understand. Once you get hold of this observable and you subscribe to it, it's also called the stream. And it's called the stream because it's basically a stream of events. And there are three types of events. We have our value event, and for the observable type, that might be 0, 1, or many events. RxJava 2 also has some specialized types that say, well, this is an observable that only emits one event, for example. That's a single. And for a single, you know it's either one event or an error. But for the observable case, we have a value event. We also have an error event, and that event is being triggered once an error occurs. And if an error occurs, then you know that your stream will be terminated and there will be no more events after that. The third option is to have a completion event. And completion event is like an error event, but without the error. So it signals you that this RxJava observable is stop emitting any values afterwards. So after you get this completion, you know that everything is done. No more value events can come in. So that's the basic observable. I mentioned a couple of times already that you need to subscribe to this observable to get these events. And subscribing is actually not that hard. You call the subscribe with method on this observable. And if you are using RxJava 1, you notice that it's slightly different. In RxJava 1, it's called subscribe. And you pass it a disposable observer, taking the type of value event that you want to have. Again, this is a slightly different name from RxJava, but the principle is kind of the same. In RxJava 2, this is called disposable observer. In RxJava 1, it's called subscriber. And this method will return an object that is called disposable, and it will allow to cancel your subscription. So in RxJava 1, this will be called subscription, but again, it's a different naming due to implementation of the reactive streams. And so we subscribe and then pass in this observer. And this observer basically has callbacks for each of the value events that I mentioned. So we have our onNext, which gets an article every time it's emitted. We have an error, which takes a throwable. So it's a very generic error handler. And as I said, once you get an error, you know that you get no more events. You are automatically unsubscribed from this observable. And the same is true for the onComplete. When you get this, you know no more events are coming. We're unsubscribed. So this is one way to subscribe to an observable. Another way to subscribe to an observable is by using inner classes. And again, this is similar to RxJava 1, but the inner class names are a little bit different. So not much change, but if you're going to refactor, you want to rename these classes. And basically what this does is the same thing as our observer before, but it takes a single inner class for each event. So we have our onNext event here, so it accepts an article. Same for the error, which accepts now a throwable, the error. And we have our completion with just no parameters, takes a run, just an action. And this notation is especially convenient when you are using this with Java 8 lambdas, which we are now finally getting officially in Android. Because you can really shorten it to this syntax. So this basically means, again, we're going to subscribe. This is the onNext event, and here you define your lambda, your inner class, basically, on what to do with that event. And same for error and completion. And for the rest of the presentation, I will be using this syntax because it's way more concise. But it's also how Android Studio would show you the notation when you are using inner classes. So it should be familiar when you're using this. Okay, so I mentioned subscription, and I also mentioned that we can unsubscribe, and you should really unsubscribe at the time that you're no longer interested in this observable. And one of the reasons that you are no longer interested could be due to lifecycle. So if you set up this observable in your onStart from your activity, it's probably very likely that you want to unsubscribe in onStop. And if you want to unsubscribe, you just call the dispose method on the disposable object that you got when subscribing. So it's pretty important that you hold on to these subscriptions. If you don't unsubscribe, you risk not only crashes but also memory leaks, because these inner classes will hold on to outer classes, which is usually an activity or a fragment or whatever. And, well, you might leak memory, which is also not good. So it's pretty important that you don't lose the subscriptions. You always need to be able to dispose the object at the appropriate time. Okay. So far, I don't think this is too complicated, right? We have an observable type, we get it from somewhere, we subscribe to it, and then we get our events, and when we are no longer interested, we unsubscribe. So this is the basics. Yet, RxJava is known for its steep learning curve, and I think that's actually true. One of the main factors why this is true is because RxJava is really an architectural change to your application. That means that you have to think in a different way about solving a problem that you might have. When you are introducing something like a HTTP library to your app, what you're basically doing, you are reducing the amount of boilerplate that you would need to write if you would write the code for doing an HTTP call yourself. But the actual structure of the code doesn't really change, right? You may go from 30 lines to 1 line. When you approach the same thing in RxJava, you'll see we'll make some structural differences. So consider this piece of code, for example, where we have this configuration object that we need to get from somewhere, and when we're initializing this class, we want to use this configuration. There's a slightly annoying detail that this configuration might not be there yet, so it might be null. And in that case, we need to find some strategy to apply the configuration later. It might be, so basically, you should probably go polling in that sense. If we would make this reactive, if we would use an observable here, then we don't care about whether this object is available at this point in time. We only care about subscribing to this object. And this means call the apply config method. So what we do, we subscribe to this configuration, and once it comes in, we know that our configuration will be applied. So that means that you are really changing the way you're thinking about this piece of code. We also now have a couple of more questions to answer, because how do we handle errors? And do we want to have every update of the configuration? Because that might happen now. And when do we clean up? We know that we should call dispose at the appropriate time. So this can be easily solved. This is just an example. It depends on what your strategy is. But for example, the cleanup can be solved by just calling the dispose at the appropriate time. We could just add a method called destroy. And we could say, for example, we are only interested in one configuration update. So we apply an operator called take one. And if any error occurs, we just resume with some other observable, which in this case will be the default config. We just apply some defaults. And again, this is just a strategy that you can employ. You can do multiple things. But I hope this points out that this is really a change to your application architecture. And that's not trivial. You basically have to rewire your brain a little bit to think about that. Another thing that makes for the steep learning curve, I think, is there's a lot of functional style. And for a Java programmer, that might not be too familiar. It's also not too hard to learn, but it might be a hurdle, especially if you're starting out your Android career here. And then we have a lot of operators to modify this stream, because actually just subscribing to an observable isn't that exciting. Usually you want to apply some extra functionality to this stream. You want to transform the data, or you want to, like I showed in the previous slide, you want to take only one, or you want to handle errors, that kind of stuff. Well, there are about, I think there are over 100, there are 100 plus operators in RxJava, and you're probably not going to use all of them, but you're sure going to use, let's say, at least 20 of them. And you're not going to use these operators standalone. You're going to use them in various combinations or recipes, as I like to say, to solve a particular kind of problem. So it takes some time to learn this, of course. You can't really expect to learn all these operators in one day. And then we have documentation. And the documentation is actually pretty complete, but it might be a little bit daunting. For example, if you look at the Java doc, we get this. There's a lot of generics, and then there's this funky diagram. If you have never seen this, it's called a marble diagram. And this diagram, its purpose is to explain you what this operator is doing. So this particular operator is called flatmap, and what it does, it takes an event and turns it into a new observable. And you can see this from the diagram. So these are the events, the circles. This means that eventually this stream will terminate. And you see that this red circle is then transformed into two diamond events. So this is a new observable emitting two events. What you can also see here is that for the green and the blue, these events are interleaved, so they are merged in a sense. And this is in the documentation, but it's quite subtle, I think, to understand this from this marble diagram. And this is just one operator. So again, I think this all adds on to the threshold for learning RxJava. So for that, my recommendation would be just to do a gentle start, right? So don't try to go all out reactive and say, this is great, let's make everything reactive. You probably, probably won't turn out that great the first time. But apply where it makes sense. And where it makes sense, I think in your domain layer it makes sense, where you're doing some data transformation, for example. REST calls, obviously. I think retrofit is one of the libraries that really make RxJava also popular, and most developers probably know RxJava due to retrofit, because now with these observables you can easily coordinate all these different REST calls. Also a very good candidate for using RxJava when you're coping with lifecycle, which is obviously a lot of places in Android, because you can easily control when you start some operation and then cancel it at the appropriate times. And in that sense, it's probably going to be a more specialized event bus. You're not pumping out events throughout all your apps. You just take this observable and subscribe to the specific event that you're interested in. It definitely has some use cases in UI, but for me personally, it's not the prime use case. It has a place, of course. You often see this named in relation to Model View Presenter, for example. So it depends on your use case. So what I want to do now is show you some examples from a real-life app that we're using RxJava in. And I'm going to start gentle, like I mentioned, and show you a simple example where we need to get an RFID tag from this article. So I will now explain where these articles come from. Articles in this context are physical articles in a clothing store. So our application is meant to scan the inventory of a store using an RFID scanner. So every article has an RFID tag and other information associated with it. So what we want to do in this case, we want to get an observable of articles, and then we want to get a new stream that represents the stream of RFID tags for these articles. And we can easily do that by mapping this object. And this is another operator. So when you apply this operator, it takes in the article, and we return the RFID tag. So we're basically mapping the article here, and we're mapping it to a string. And that's all there's to it. What's important to realize, though, is that this observable is immutable. So once you do this observable of map, you're basically creating a new observable. So that's important to keep in mind. So it will wrap the observable that you pass in, and then will give you that observable. And again, nothing will be executed when you call this method, right? Only when you subscribe to it. Now I'm going to show you a more real life, but also a little bit more complex example. I'm going to talk you through it. So we have this requirement that we want to count all the articles in our store, and we want to group them by type. So we want to process only the articles that are supposed to be in stock, and we know from the inventory this article we expect to be in stock. And then we want to group all of these articles by their ID, and we can see that from the RFID tag. And we want to then count all of the articles that are similar. And we want then have a stream that emits one object for each article ID with the count of how many articles we've seen of that type. So if I'm in this store and I'm scanning, for example, 5 white t-shirts and I'm scanning 10 green t-shirts, I want to have a stream that emits 2 value events, one for the white t-shirts and one for the green t-shirts. And this is the code that produces that. I'll let it sink in for a couple of seconds. So I'm not really telling you that this is like trivial or easy code, but it is code that you might encounter when you are onboarded onto some app that uses RxJava. So that is what I want to leave you with, to keep this in mind. But I will also explain how this code works, so to understand how powerful this actually is. So, like I said, we want to filter for the articles that are in stock. So let's suppose we get this observable, and we're now going to transform it basically. So we're going to filter the articles that are in stock. And there's a simple operator to do that. It's called filter, obviously. So we get the article, we return where that is in stock, and we have now created a new observable that only contains the articles that are supposed to be in stock. Now we're going to group these articles. And again, there's a convenient operator for that called group by, and you pass it a function that takes an article and returns some kind of key. In this instance, I've chosen to return the article ID for this article. And let me show you the marble diagram for group by. Yeah. So when I saw this the first time, I think my head exploded a little bit. Because there's all these symbols here, and what is this thing doing? So what group by does, it takes these circles and these triangles, these represents the different type of articles. And then it will group them not into new value events, but a value event that is actually a new observable. So it's a little bit of an inception here. We're getting in this example, we get 2 groups back, but each of these groups in itself is an observable. So yeah, learning curve. But once we have that, we now have this observable, which is of type group observable with a string, which is the key of the group, and an article. Now we want to process each of these groups individually. And we can use the flat map operator that we've seen, because flat map, again, converts an existing observable to a new observable. So we take each group, and by then it's we're basically unpacking this observable into a new group observable. And now we want to get every item in this group, so our white t-shirts or our green t-shirts, we want to convert it into our article quantity object. So what we're going to do is for every event, we're going to map it into this new object. And so if we have 5 t-shirts here in the group, it will result in a new observable creating 5 value events. But we're not there yet because we don't want 5 events for all these t-shirts. We want 1 event representing the total count. And again, we can apply another operator for that. In this case, it's called the reduce operator. And what reduce does is pretty simple. It takes a previous event and a new event, and it expects you to return a new object representing the count, basically reducing it from 2 values into 1. So in this case, we just get these 2 articles. They both have the same ID because it's the same group, and we can just sum them up and return it. And once we've done that, we finally, if you trace it back, so we now have for each of these t-shirts we have created, if we have 5 white t-shirts, we have now created 1 object. We did that for every group, and the end result is that we now have 1 observable that will transform the whole article observable that we pass into this powerful function. And again, nothing will be executed when you call this. Only when you subscribe to the final observable that we return, all this processing is going to happen. So I hope you agree that this is really powerful. I mean, the simple map example that I showed, you could easily do that with a for loop. But this stuff is way more complicated and also so powerful. Because this observable might come from a database, might come from a network. It doesn't really matter. As long as you can represent it as an observable, it will transform it. But I hope you also agree that this is not trivial, right? Along each step of the way, you have to think about how am I going to convert this stream of one type to another type? Which operators do I need to use? I already used 5 in this example. So you need to know about these operators. And you also need to know that group by, for example, requires that the stream completes, which is kind of obvious because if you want to group stuff, you need to know how many of those things you have. But still, it might bite you when you try this on a stream that doesn't complete, because simply nothing will happen. Okay, so again, if you didn't get all of that or any of that, keep in mind this is very powerful, but it takes some time to learn it. Now I'm going to switch gears a little bit. So far, I really talked about about any threading or scheduling, which, if this example before was coming from a network call, it would basically crash your app when you subscribe to it, because all of your operations would be on the main thread. If you don't want to do that, and you basically don't want to do that when you have anything that reaches out to the network, you can apply a scheduler. And schedulers are basically pools of worker that you can apply to your observable. And there are some built-in ones like schedule.io, computation, but you can also create your own one from an executor. And then for Android specifically, there's the main thread scheduler, which allows you to usually get the result back on the main thread once you want to process your result. And there are 2 operators involved for applying these schedulers. There's the subscribe on and this observe on. Subscribe on controls on which thread the work is being done once you subscribe. And this is important to understand because that also means that you basically can only apply it once. Because if you would apply it multiple times, you basically spin up a thread to do some work, which then spins up a thread, which etc., which is just a waste of resources, basically. On the other hand, observe on controls on which thread a value is being emitted. So observe on you can apply multiple times, because you might want to do some processing on the background thread, do something on the main thread, and then switch back to a background thread if you do more processing after that. And in this example, you can see we do a map, and this has an operator, subscribe on, so it's basically working in this direction. So the map is now on the background thread. And then we have this observe on, and we give it a main thread, and we have a flat map. So observe on is basically working in the other direction. Okay. So there's one caveat here, is that some operators bring their own scheduler. So even if you do this, you might think I'm doing the right thing, and then you apply, for example, a timer. A timer might run on a different scheduler with the effect that once you process your value and trying to update a view, for example, it will just blow up because you're still on the background thread. So that's something to keep in mind. You can supply your own scheduler to operators like timer. But yeah, you might be bitten from that. Okay, let's talk about some common mistakes that I've seen people made on projects, which some things that I might or might not have done myself. Yeah, so I'll give you a couple of mistakes here. So I think the number one mistake that I've been seeing in projects is not keeping a reference to your subscription. And again, if you don't keep a reference to your subscription, you're unable to cancel this operation, which might lead to crashes or memory leaks. So it's really important that you keep a reference. So one way to keep a reference is to use a composite disposable object. In RxJava, this is called composite subscription, but it's basically the same thing. So what you would do, you have this field in your class where you're doing some lifecycle work, for example, and on start you want to do some work. So you subscribe to it and you put the disposable in this composite disposable object. And once you want this work to clear out, so you can add multiple things here, right? So once you want to cancel all of these operations in one go, you just call clear on the object. And clear will then unsubscribe or dispose all of these subscriptions. And it's also important not to use dispose. There's also a dispose method, but dispose will basically render the whole object unusable in the future. If you then add more stuff to it, it will immediately dispose your subscription. So in the context of Android, you probably want to use clear always, because then you can reuse this object. So this is a nice trick to make sure that you cancel at the right moment. Yeah, another common mistake that I'm seeing is around error handling, or rather forgetting to handle errors. Especially when you're using this lambda notation, it's pretty easy to not supply an error handler. And if you don't supply an error handler, then, especially if you're using a scheduler, you end up with these stack traces which basically tell you nothing. It says, well, it crashed in this and that thread. But it doesn't have a reference to where you actually subscribe to it. So if you are using an error handler, then you can log it, or you can throw another exception there, and then your stack trace will have this location where you subscribe to it. Even if you're using an error handler, it's also important to log the error that you're getting in, because as you remember, the error handler is a very generic throwable. So you might be thinking that you're handling all these errors correctly. So you might be expecting IO exception, for example, but then you made a little mistake somewhere and it throws a null pointer exception. So that also goes to the error handler. If you're not logging that exception, you're just staring at your screen now because you think you've done everything right, but nothing is happening, because you basically are swallowing this exception now. So I would recommend always to log it. I've also written a little lint check that can flag the situation where you might be forgetting these error handlers. There are also other tools that do that, which might be convenient. So if you forget the error handler, it will give you this red squiggly in your code and say, hey, you forgot to handle these errors. And then you can either decide to, yeah, I know what I'm doing, just ignore this error, or you can do the right thing and then implement the error handler. This is a more peculiar one that I've seen in code. So this is like, I think this must be a beginner thing, but we're doing everything right. We're creating this observable, we're applying the schedulers, and then we subscribe to it, and then once the stuff comes in, we're just getting the event bus and we post this event. And if there's something wrong, we are catching the errors, great. And now we're throwing another event bus thing. But the thing is here that you've now basically recreated an async task. You can't really cancel this thing anymore once it's being processing. And you're not really doing anything with the whole reactive pattern. What you should be doing there, of course, is, again, create the same observable, but then subscribe to it so that you can easily get the value and the error, and you are able to cancel it now. So it's surprising, a little bit surprising to me that I saw this a couple of times, but so I think it made sense to call it out here. But that also relates to, for me, that relates to the different way of thinking how to approach things. Right? It's not just a method to do some background work. It's more than that. It's more an architectural change. Another thing that I'm seeing is it might be tempting to break the stream, so to say. So you might have this operator, you do a map, and then you need to call out to some function. Basically, if this other function is also doing a subscription, you are now losing the subscription. You don't want to. So you probably need to do flat map in this case. If you do want to have some side effects, then there's the do on something methods that you can also apply to your observable. So, for example, do on next would now log every value in this stream. Also have a couple of tips for you. So one tip that I would have is try to compose your observables. If you're writing RxJava for the first time, you might end up with this observable you do, like map, flat map, filter, whatever. And before you know it, you have this method which is like, I don't know, 100 lines. So what really helps is to try to split up these functions where you create separate observables. For example, if you do a flat map, you return a new observable, that might be a new function. Seems like common sense, but it's a kind of a trap that you can fall into when you're doing this chaining. Also, try to apply these schedulers as late as possible, because if you're doing this all over the place in your app, it's probably more convenient to just apply these schedulers where they make sense, right? So if you're always doing background thread, then switch to main thread, this code is just much more clean. Last tip, and this is a little bit particular to RxJava 2. So RxJava 2 throws errors that RxJava 1 wouldn't throw. RxJava 1 would basically swallow some kind of errors. Basically, errors that are internal to the library. You might get into a situation that an observable is violating its lifecycle, meaning that once it threw an error, it is not allowed to throw another error. RxJava 1 would just ignore that. RxJava 2 won't ignore it and will throw you an undeliverable exception, and not in any case you can catch this exception. So I recommend you probably end up doing something like this, where you catch this particular situation, and then if it's not an undeliverable exception, you'll just delegate to the normal handler. Yeah, so this thing I'll leave as an exercise for the reader. You might go all out with RxJava and think, I got this, but this is basically rewriting a for loop. It is not really using anything reactive. So I wouldn't really recommend to do it like this, but if you want a nicer way to iterate your list, for example, look at some more functional language like Kotlin or that kind of things. So concluding, it's very powerful. It's a different way of doing things, and I recommend to take small steps learning it. And with that, my presentation is incomplete, so thank you very much. I'm not sure if we have time for questions. Do we? One question, maybe? Yeah. Anyone has a question? If we have questions, though. No questions? No questions? No questions? No? No questions. Well, thank you.